Hello.
Yeah, I can see now.
Okay. Rajesh garu.
Okay. So,
Hello, Rajesh garu. Voice
discussing,
వినిపిస్తుందండి?
is my voice audible?
Hello.
Sir?
Hello. Hello.
Hello. Hello.
Yeah, Rajesh.
Deep, are you able to hear me?
Yeah, I can hear now.
Hello. I can't hear anything.
Can you hear me now?
Yeah, I can hear you now. So in the last session we were discussing, I guess, did we discuss about the implementation? I think we were discussing the between these two, and we have ended it, right? So let us try to understand the components of a data warehouse architectures. What are the different components available as part of the data warehouse architecture? So to start with, we have a source component. So if you see in this particular diagram, you've got a source databases, you have got the data cleansing tool, ETL tool, the warehouse, this is your warehouse. These are all the different components. Now take the example of any company. Every company will have their source applications where the data is being stored in the source databases, and you use your ETL tool to cleanse the data, right? And then you transform the data into the staging area, and then you move the data to the warehouse, right? So before we could move the data to the warehouse, first of all I need to build the metadata. I need to build the metadata in my warehouse. So only when I build the metadata in my warehouse, I'll be able to push the data from my source databases to my warehouse. Any doubts in
Rajesh,
this
where is the stage
architecture?
area?
Staging area will come into the picture, like it's just a smaller picture of the data warehouse. The ETL tool, what you are seeing, this is the place where all your staging will be done. From
Okay.
the source databases, it goes to the staging. Staging is the place where you are seeing the ETL tool. So in that, that is the area where we call it as a staging area, or it's a temporary area where first you extract the data from the sources and move it to the stage, which is where you see the ETL tool. You do the trans, and then finally you move them to the warehouse. Right. So here the warehouse, using your data modeling tool, you create the metadata. Metadata is nothing but your data warehouse metadata, or the schema where you build your data warehouse. And you have an administration tool through which you actually monitor your data warehouse databases. Probably you will monitor your ETL runs, you will be monitor your data warehouse data, how much data is being loaded. So all these are your admin related active do as part of your. So, and then from the data warehouse we have got again something called data marts. Data marts are nothing but they are mini data warehouses where you from the data mart, say for example in your central warehouse you might have subject areas, like you might have a finance subject area, you might have a marketing subject area, you might have a HR subject area. So when you say enterprise data warehouse, it's a combination of multiple subject areas, right? From there I might create multiple mini data warehouses, which is also called as a data mart. So from here, from the warehouse you create a data mart, which could, the structure could be a rollup based structure, or it could be a RDBMS structure, or it could be MDDB. Any idea what is MDDB, Sandeep?
Not sure.
It's a multi-dimensional databases. Cubes. Heard about cubes?
Yeah.
Cube is again a different structure. It's a multi-dimensional structure. Yeah. So you can actually create data marts in different structures. It could be a RDBMS structure, or it could be a multi-dimensional structure, or it could be a purely relational overlap structure. Okay. So once you create these data marts in different structures, you use different reporting tools. For example, OBIEE. OBIEE is one of the tools which you use to create reports out of these data marts. So this is typically the whole warehouse architecture. Now, right now, if you ask me where OBIEE developer will come into the picture, it will be in the last layer where you have data access and analysis tools. That is where your OBIEE developer comes into the picture. So from sources till the data moves to the data warehouse or data mart, it's all the ETL team's responsibility to move the data from their sources to till the warehouse or till the data marts. Any queries, Sandeep?
No, Rajesh, fine.
Yeah, right. Yeah. So let us try to understand what are the different approaches for implementing a EDW. So for implementing an EDW, standardly there are two standard architectures which are there. So one is called a top-down approach and the other one is bottom-up approach. So let me just give you. So before we can go ahead and understand about the approaches, let us try to understand enterprise data warehouse. What is an enterprise data warehouse? It contains detailed as well as summarized data. It contains detailed as well as summarized data. And we have, if you look into your enterprise data warehouse, it's a combination of different subject areas. You could have a finance subject area, you could have a HR subject area. So your enterprise data warehouse is nothing but it consists of separate subject-oriented databases, right? Supports detailed analysis of business trends over a period of time. One of the main advantages of having a warehouse is it should support the trend analysis. So over a period of time, how is you going to do the forecasting? You wanted to do a sales forecasting or production forecasting. So all these kind of business solutions you can do using your enterprise data warehouse, because you are storing your historical data. Since you have historical data, you will be able to do all these kinds of advanced analysis. It is basically used for short and long-term business planning. So if you try to compare the operational system and the data warehouse system, basically if you look at operational system will be used by your operational staff on a day-to-day basis, But when it comes to the data warehouse, it is used by your top management and it is basically used for short-term, long-term business planning. So it's like the top management will not be using your warehouse every now and then. It's like only when it's required. That means on a ad hoc basis they will be using these. So let us try to understand the different approaches through which you will implement your data warehouse. So standard, I'm not sure if you are having an idea about like data warehouse, like pioneers in data warehouse, because there are two people. One is Kimball and there is another person called Inmon. Heard about these two guys?
No.
So Inmon is the person who has advocated this top-down approach. So basically when the data warehouse started coming into the industry, this guy has advocated this particular approach. What he says is, this data from the source system, first you pull the data from different sources and move it to the staging, and from staging you move it to the data warehouse, enterprise data warehouse. That means you have to create all the different subject areas at one go. At one go, you need to create all the subject areas. So that is what a top-down approach talks about. So once you have your enterprise data warehouse in picture, from there you start creating data marts. From there you start creating data marts. So as I said, data mart is nothing but it's a mini data warehouse, or for every subject area you create a separate data mart. So if you look at this approach, what he is trying to do is, first he is creating the enterprise data warehouse which will include all the subject areas, and then based on the requirement they will start creating the data marts for each department. So if you look at the implementation, implementation, again, as I said, it is composed of multiple subject areas. So when you create a EDW, it is a combination of multiple subject areas. And then once you create this enterprise data warehouse, then you start constructing multiple data marts, right? So this is how you do this. But if you look at the advantages and disadvantages of this approach, though it is a coordinated approach and you have a single point of control, problem is, like, to implement this kind of approach, it's going to take a long time. Imagine you need to interact with multiple departments, it's going to take a lot of time. So typically to implement a warehouse in a top-down approach, it's going to take at least a year's time. So at least a year's time. So year is a very long period. If you talk about software development, if you're taking a project to implement, if you're taking 1 year to implement a project, that's going to be very long. So the disadvantages for this particular approach is that, the analysis paralysis. That means whatever requirements, whatever analysis you have come up in the starting, when you start the project, those requirements might not hold good at the end of the project, because the requirements keep changing, and 1 year is a too long period that the requirements they don't hold good, at the end of the implementation. So that is one of the main drawback, where the requirements, 1 year cannot hold the requirements, right? So that is one of the major problems with this approach. Scope control, as I said, when you define the scope initially, when you start the project, you might have defined a scope. Let's say, suppose you wanted to create 10 KPIs. So you say that this is my scope, and by the end of the 12th month, by the end of the year, once you start completing and handing over the project to the customer might come up saying that he needs 5 more KPIs. That means the scope, you cannot control the scope, or because the time taken to implement this approach is too long. Time to market is also too long. 1 year is too long. And risk and exposures, there are so many risks which are involved if you go for this approach. Like 1 year is too long that the people who are working in this project might resign, might go away, right? So these are some of the risks which are part of this kind of approach, right? So to avoid those problems, Kimball, there's one more guy called Kimball, he has advocated this approach, which is called bottom-up approach. So the difference, if you try to, can you spot the difference between these two approaches? Sandeep, what do you see the difference between that and this approach? If you see this and this approach.
Yeah. First, everything will come into data warehouse, then dividing. Now, already divided,
Correct.
then it's coming to enterprise data warehouse.
Correct. Right. So over here, what Kimball says is, instead of developing the enterprise data warehouse at one go, what they do is they will first talk to a particular department, let's say finance department, right? And then they understand their requirements, they understand their KPIs, and they construct a data mart for finance and give it to them. So hardly it will take 2 to 3 months to develop a data mart, and people will start using that. And then they talk to another department and they develop a data mart for that department. Likewise, they start creating this in small slices. That means whatever problems you are coming across in the previous approach, you are trying to avoid those problems by cut-shorting the time. So now the implementation time for these data marts is much lesser. So within 2 to 3 months you are able to give away one data mart to the customer. So that way customer is able to start using the data mart, he is able to create reports out of the data mart. So that way this a good approach. Right now if you look at the industry, people are following this approach. So if you look at the implementation, to start you need to create a enterprise data mart architecture. So if you see this layer, before you could actually come up, or before you could actually start with the data mart development, first we need to ensure that enterprise data mart architecture is in place, right? So you create a blueprint of this architecture, you come up with this architecture, then you start creating the data marts. So first you create one
Rajesh,
data
one
mart,
second.
subsequently, yeah.
Can you go back to the slide, bottom of slide?
Yeah.
Yeah, this one, data marts are already created, right?
Before creating, you
Before
should create an
before
architecture.
enterprise data mart, already data marts are created, and from there reports are generating. They can make the reports, and users can, top management can use from there. So then what is the use of this enterprise data warehouse again? Only collating or
Right.
anything else?
That's a good question. So the advantage of having enterprise data warehouse is, see, when you look at data mart 2, okay, when you look into the data mart 2, you will not be able to get information from data mart 1. So there is no interaction, there is no communication between DM1 and DM2. So if a top management want to see a integrated view of all the data marts, my top management want to see an integrated view of all the data marts. In such a scenario, he has to go to the enterprise data warehouse. Are you getting?
Yeah, here also you are constructing one enterprise data warehouse which takes 1 year, right?
Where in
In the
this
top,
approach,
no, here
right?
it's so,
But
here it takes long
no,
time. That is the reason you are going for a bottom up, right?
correct. In bottom up, what will happen is first 2 to 3 months I'll give away the DM2. Okay, so DM2 will be, the people will start reports. They will not wait till the enterprise data warehouse. They will start using the data mart and creating reports out of DM2.
But top management cannot take the decisions by taking all the different fields, right? In this way also.
Right. No. Here the advantage is you have to prioritize the activities. Like whichever department requires the highest priority, for that particular department, you will create a data mart. Though you will not have a integrated view in the initial stages. In the initial stages, when you start developing for the first data mart, you will not have an integrated view because at that moment of time, you might not have developed the other data marts. You might have developed only one data mart. So you will be only the, let's say suppose first you are developing finance data mart. So only the finance department will get to create reports. Then they create, let's say DM1 is marketing. So marketing department will start using. And then, so department wise, you are creating different data marts. Finally, people will start using the individual data marts. But the integrated view can be captured only once you have an enterprise data warehouse in picture.
Okay, got it.
Okay, no? So initially you will not have integration between the data marts. There will not be an integration between the data marts. So slowly, once you develop all these things, and before you start developing all these things, you would have already created an architecture. Architecture means that architecture will accommodate all the different data marts inside that particular architecture. That bus architecture, data mart bus architecture. In this data mart bus architecture, what you do is you start creating an incremental data mart. So first you create one data mart, then you add another data mart. So you will ensure that there can be an integration at the end of be able to integrate these data marts. Queries?
Fine. Understood.
Any queries? Fine. Yeah. So this is what we are saying. So initially, before we could start data mart development, first and foremost thing what we need to create is EDMA architecture. Once we do this, then we start developing the data marts. But if you look at the pros and cons of this approach, you have quick return on investment because each department will get a chance to play around the KPIs, play around the data mart, and low risk, low political exposure, whatever kind of risk which we used to have in the top-down approach, we are not having, like employees leaving the company or employees leaving the project or budgetary constraints. All these things will not be there. When it comes to delivery, it will be very fast, focused problem, focused team. So since it's a very short span of time, so you would identify the problem and then you come up with a solution and give it to the end user. So it is all focused problem and focused team. and inherently incremental. As I said, it's a incremental. So you create one data mart based, typically you start creating similar kind of data marts for different departments. So the downside to this approach is multiple team coordination. Since like there will be multiple teams involved in this, coordination might be little difficult, which is a challenge which needs to be attended. And you should have a EDMA, that is Enterprise Data Mart architecture, to integrate these data marts. So one of the main reason of having EDMA is you should be able to integrate the data marts. So that is the reason we start with the EDMA as part of this process. Yeah. So these are the two different, as I was telling you, Ralph Kimball is the guy who has advocated the bottom-up approach, and Inmon is the guy who has advocated the top-down approach. These are the two, good books which you could actually refer. Yeah. So data warehouse features. So we very well know the main purpose of a data warehouse is strategic enterprise level decision support. So it supports the enterprises in taking strategical decisions. Multi-dimensional view, one of the most important things is your warehouse is multi-dimensional. So we'll see what are the different kinds of multi-dimensional structures which are available in the coming slides. So it caters to the entire spectrum of management. What do you mean by entire spectrum of management? So it caters to different departments like finance, HR, supply chain. Take any department, you'll be able to help all these departments. So descriptive and standard business terms. When we talk about data warehousing, unlike the operational systems, the schema, the start schema or the kind of schema what you create out of your data warehouse, it will be in a standard business terms. So I'll be showing you in a start schema. It's very simple to understand the start schema. High degree of scalability. So data warehouse is built, keeping in mind the scalability, issues and all. Since you're storing huge number of records, since you're storing historical records, so the kind of infrastructure what you make it available for these data warehouse will be huge, so that it can be scalable. Analytical capability, that is one of the major advantages of having a warehouse. Since we are having historical information, we will be able to do lot of advanced analytics. Historical data only. So as part of your data warehouse, we will maintain the historical data in your data warehouse. So these are some of the application areas where your data warehouse can be implemented. So this is not limited to only these, but these are some of the applications where your data warehouse can be implemented. Okay, so let us try to understand the data modeling structures. So when you look at the data modeling in terms of the two things what we have discussed, the operational systems and the data warehouse system. So whenever we talk about the operational systems or the transactional systems, that modeling which is used to create a transactional system is entity relational, it is ER modeling, and the modeling what we use for data warehouse is dimensional modeling. So let us try to understand these two techniques. When we talk about relational modeling, it is basically used for implementing the transactional system. Relational modeling is basically used for implementing the transactional systems. Take any transactional systems, ERP, CRM, all these systems are implemented using relational modeling. And one of the main features is it is very difficult to understand by non-technical folks. So business users will not be able to understand the structure of the relational model. So that is one of the reasons they hire a separate IT department. If you take any ERP or a CRM implementation, you will have an IT department which will be supporting the end users, for creating reports. Did you ever come across such a scenario, Sandeep, where you have a separate IT department?
Actually, I didn't get this relational modeling.
See, relational modeling is in the last session, if you remember, we were discussing about normalization.
Yeah, I understand that for transactional operational kind of systems, they use this one. relational modeling, data
Correct.
modeling.
Correct. Correct.
You're saying it's
Which
difficult
is nothing
to
but
understand for users.
right.
So the
It is
example what
difficult to
you're saying,
understand.
I was not understanding.
The example what I'm saying is, let's say suppose end user wants to create a report. He wants to create a report. So to create a report in a transactional system, it is very difficult because the structure of the operational systems, the number of tables, it will be huge. There will be so many joins. If you remember, we are talking about the normalization where the number of joins will be so many in case of operational system. In case of normalization, in case of relational database management system, you will see that the number of joins are very high, like the number of joins are very high. Because of so many joins, it will be difficult for a non-technical user to understand the structure. Example, let me show
Okay,
you one
I
structure.
understand that. The thing which you are saying, ERP guys, some CRM guys.
Correct. So what I'm saying is, you take any of these implementation. Let's say suppose XYZ company has implemented a ERP solution. When I say ERP, ERP is a transactional system, right? So they capture the business transactions and keep it as part of the ERP database. And the end user, if we want to generate reports, what they do generally, they raise a request to the IT department to create reports. That means there is a dependency for the business users. They depend on the IT team to create reports. They depend on the IT team to create reports from these transactional systems. So business users will not be in a position to create their own reports because it is very difficult for them to understand the schema. It is very difficult for them to understand the transactional schema. You getting it?
Yeah, I understood now.
Yeah. So the reason you take any, if you have worked with any ERP or CRM systems, you might find a separate IT department where the business users will be raising requests to create reports, to create transactional reports. So coming to the performance, one of the limitations with the relational modeling is performance will be poor. Any reason? Do you know why it is very poor performance?
It will be huge system, right? So obviously it will be raising many requests, and to get the data from many
Right.
people, it will be
But the most,
obviously poor performance.
yeah, yeah, but the most important point you should not forget is the number of joins.
Yeah, yeah, yeah.
If you remember, yeah, the number of joins will be huge when it comes to a relational system. A relational system will have too many joins. But when it comes to the dimensional modeling data warehouse, it will not be too many. It will be very, very limited. So the other day we have seen the differences between a star schema and a normal relational system. So in a star schema, we try to reduce the number of joins, but increase the duplication. Over here, it's the other way around, right? And when you talk about the dimensional modeling, this is basically used for data warehouse creation. So in order to create a data warehouse, you use a
Rajesh, 1 second.
dimensional. Yeah,
You said yesterday normalization and denormalization, right?
correct.
So in normalization, what do you say? Operational kind of systems will be used, right?
Correct. This is operational.
Okay. The
Or
other one is
the other one is dimensional modeling, denormalization. Or
denormalization, which is this uses a data warehouse, right?
this is basically a data warehouse. In a data warehouse, you will have a denormalized schema. So what will happen is here less number of joins.
So
And
users will directly do the reports here.
yes, yes, yes. One of the advantages with the OBIEE tool. If you see the other day I was showing you, right? You don't have to write any query. You just drag and drop the columns. So the end users will be directly creating their reports. End users can directly create their reports.
Okay, okay.
So that is one of the advantages with data warehouse schemas. So it's very easy to understand by the end users. But
Because I am working in this only. I was not sure where exactly I am fitting now to normalization, operational transaction system.
right. You said you're working for some CRM based customizations, right?
Yeah, yeah, yeah.
Right. So you're
QRM,
purely
QRM.
into
We work
transaction.
on the application QRM.
Okay. Okay. So you're into this, right? In that case, so probably
Yeah.
whatever databases what you manage over here, it will be purely relational.
Yeah, so from source we'll get from source service we get a data and we process in accordingly with a QRM application where
Okay.
application creates and what do you say tables mapping everything done in that only
Okay. Okay. Okay.
and we generate reports.
Okay. So that is what I was telling you. So basically you're working for the IT department, right? And you get the request from the business users.
Yes, yes, yes.
Right. So in case of data warehouse, what will happen is, if a user is having a OBIEE reporting, if the company has implemented OBIEE, then as a BA developer, what we do is, as a BA developer, we just create the metadata layer. We just create the metadata layer and we deploy this on an application server. On a application server. So once you deploy this on an application server, end users can make use of this. End users can create reports using this metadata. Can create reports using the metadata. So this is how it works in OBIEE. So the other day I was showing you the metadata. So metadata is nothing but
Yeah,
it is
now
a,
I got little good picture.
okay, good, very good. So yeah, as and when you start listening, right, slowly all the things, right, the gaps, whatever gaps which is there, they'll be like slowly, logic.
Whenever you feel,
So,
you're giving examples, right? You relate to practical itself because it's somewhat
uh-huh.
easier to understand.
Okay, okay, fine. Yeah, I'll be doing that. I'll be doing
Yeah,
forward.
yeah.
I'll be doing that. Generally, since it's a starting, right? So normally what will happen is in the initial pictures, like what we'll try to focus more on the technical part, like when you talk about joins and all. When we talk about normalization, I'll have to mention that normalization means more number of joins. Denormalization means less number of joins. These are some of the fundas, like thumb rules. Whenever, otherwise you will forget. Otherwise,
Yeah,
normally
yeah,
what we
that is fine.
forget,
I
right?
understood. Yeah, I'm understanding properly. No.
Yeah, yeah. So up to here it's clear, right? So
Yes, yes,
your
perfect,
dimension.
perfect.
Next, if you talk about what is a database normalization, it is a process of efficiently organizing the data in a database. So most of the times I'll be repeating the terms over here in this throughout this session. The more you try to repeat, the more you'll be able to recollect or remember it. So I'll be repeating you might have observed, I'll be repeating the data warehouse features here and there. That way it will be easier for the student to understand and remember those topics easily. Okay. So if you remember the last class, I was talking about the normalization. So there are certain rules as part of the normalization. Those rules are nothing but normalization rules. These are your first normal form, second normal form, third normal form, like that. These are some of the forms which the database developer has to implement while creating the database, while creating a transactional database. So as part of that, one of the features what we say is we eliminate the redundant data. We eliminate all the redundant data and we will ensure that data dependencies make sense. That means the other day I was explaining every table, whatever columns which are there in that table, they will have to depend on the primary key. They will have to depend on a primary key. So when I say employee table, all the columns which are part of the employee table must depend on the primary key of that particular table. So that means you are only storing the related data in that table. Right? So this is what you are trying to do as part of a normalization. So as part of a normalization, what we are trying to do is we are trying to reduce the space and by increasing more number of joins, and you are making it complex. By increasing the number of joins, you are making it complex. And one more rule what you are defining is whatever columns you define as part of a table, they should have related data. They should have related data. Be able to connect these 2 points? Sunil? Let me know if you're not able to get it. I can explain. No issues.
No, I'll raise immediately. I'm understanding.
Good.
Because
So,
even if I
that's what. So,
get us struck up there itself if you go forward also.
okay, fine, fine. That's good. So again, when we talk about denormalization, we are talking about involving duplication. So we are introducing duplication and we are eliminating time-consuming joins. By doing these 2 things, you are actually improving the performance. You are improving the performance of the reports. So whenever we say denormalization, we should remember it is about star schemas and it is about dimension modeling. Whenever we say normalization, it is about RDBMS or OLTP systems or OLTP systems. So objectives of denormalization is easy navigation during data analysis and it should be more intuitive. So it is business user friendly. That means this is business user friendly. Right, and this is developer friendly. This one is developer friendly. And when we talk about the EDW schema design, so enterprise data warehouse schema design, what the end users want is it should look like a business. It must look like a business. So for example, if I show you this schema, this is a typical star schema. So in between you have, this is a fact table and these are all your dimension tables. This is a fact table and these are all your dimension tables. So using this schema, I can easily tell that customer-wise orders, I can create a report called customer-wise orders by joining these 2 tables. I can create product-wise orders by joining these 2 tables. I can create time year-wise orders by joining these 2 tables. So that way, if you see, this is a very simple schema, right? Even any end user without any technical knowledge can easily understand, and it doesn't like any technical stuff. It's all business user friendly language what we are using here, isn't it? So it must be recognizable by business user. That's what it should be. Business user friendly, approachable by business user, and it must be simple. And the types, there are different types are there: star schema, fact constellation schema, snowflake schema. These are the 3 different types. We will see one by one. This is a typical star schema where nothing but you have a fact table surrounded by multiple dimension tables. You have a fact table. Fact table is a table which will hold all your facts, all your numeric data, whereas your dimension tables will store all your descriptive data. It will, like if you take about the example, if I give you an example, let's say suppose this is a product and this is an order table. Now I wanted to see product wise sales. Let's say you take the example of Walmart. Under Walmart, under product you might have, let's say baking products are there. So baking product wise sales you wanted to see. So I can create a report by joining these 2 tables and can generate that report. Similarly, country wise revenue I wanted to find. So I can join this country dimension with my order fact table. I can join my country dimension with order fact table and can develop my country wise reports. So in a star schema you will have only one fact table. You remember, in a star schema you will have only one fact table. Rest of all are dimensions. Rest of other tables are dimension tables. Then you have a snowflake schema. A snowflake schema is again, it's an extension to the star schema. If you see, this country dimension is again extended to city. This country dimension is extended to city. So this way you are trying to normalize over here. You are trying to normalize your country to the city. So this is your snowflake schema. Snowflake schema, what will happen is, if you compare the difference between a star and snowflake schema, your star schema is simple, whereas your snowflake is complex. In a star schema, it is denormalized. It is denormalized, whereas in snowflake schema, if you see here, you are normalizing it by extending. You are having one more join over here. So this way you are normalizing your schema, and less number of joins in a star schema. So if you see the star schema, you have, there is only one join. There is only one join between these two tables. There is no other joins. But when it comes to snowflake schema, you have more number of joins. Since there are more number of joins, the performance also will be little poor when you compare with your star schema. Performance is good over here, performance is poor over here, and it is easy to navigate and it is difficult to navigate. So these are some of the differences between your star and snowflake schema. Types of tables, okay, I think we got so many things. So what we'll do is we'll wind up this for today over here. Any doubts still what we have discussed in today's session, Sandeep?
It's fine. I don't have any doubts.
Okay, okay. So what we'll do is, like, tomorrow's session we will start discussing about facts constellation, and there are different types of tables. When you talk about fact tables, there are different types of fact tables we will be discussing. We have several types of dimension tables we will be discussing. So these are some of the structures what you find as part of your data warehouse. As part of your data warehouse, you will find these types of tables which we'll be discussing in tomorrow's session. Yeah. So fine, I think that's all for the day. So if you have any queries, just let me know. Otherwise, we'll wind up for the day. Let's meet tomorrow, same time, 7:30.
Raj, is it possible to start at 7 because 7:30 it's getting late, and today it has only 45 minutes.
No, actually problem is by the time I leave the office, right, it will be 6:30. I cannot come out of office before 6:30. And by the time I reach home, if there is no traffic, at the most I'll be reaching by 7:15. Otherwise, if there is traffic, right, it goes beyond that. So that is the reason. I'll try
Okay.
in case if it's possible. I'll try in case if it's possible. I'll just ping you. In case if it's not possible, we'll have it 7:30.
Yeah, so if you come to home a little early, 15 minutes before also, we will be ready to join.
Fine, fine. That way, then we'll do that. Yeah, definitely. I'll intimate. In case if I'm a little early, we'll do that. Definitely, we'll do that.
Yeah.
Yeah.
And
So fine. The next, yeah.
I didn't get any course content, any regarding any what is material, nothing I didn't
Oh,
get.
is it okay? I'll ask Raidu. Are you there? Raidu? Okay, I'll ask Raidu to share this. Today itself
Okay.
we'll be sharing. Huh?
Okay, okay.
Fine, Sandeep. Then. Let's meet
Thank you.
tomorrow.
Thank you.
Thank you. Yeah.
Hello. Hello.